Hi, I'm Chris from Pro-M Racing. In this segment, we're going to talk about how to install the new Pro-M EFI engine management system into a Fox body Mustang. And while we're at it, we're going to talk about some of the common mistakes people make on their cars and how to prevent them. Our management system for the Fox bodies consists of the new Pro-M EFI processor, a new EFI wiring harness made specifically for the Fox bodies, tuning software, and a cable that goes from the USB port on your laptop to the OBD2 diagnostic connector in the new harness. It is a mass air, sequentially fired, port fuel injection system with full ignition control. The processor is pre-programmed from the factory, offering the only true plug-and-play system on the market. All you need to do is enter some basic information and you're done. However, it is fully programmable. The Pro-M EFI engine management system will allow you to do anything you could possibly imagine to your engine and control all of it with easy-to-understand parameters all in a single processor. You do not need a spark box, or boost timing control, or nitrous controls, or anything else for that matter. It's all here in one system. No one else offers a system so effective, so complete, and yet so easy to use. We invite you to compare our system to anything else on the market. Guys, if you're using a speed density system, you're working too hard or not getting the results you should be. Probably both. Also, if your EFI system doesn't control ignition, it's only doing half the job. Don't confuse ignition reference with ignition control. Many systems have an ignition reference input. That is not ignition control. Engine management is air-fuel ratio and ignition control. If it's only doing fuel, you only have half a system. You wouldn't install half an engine, so why would you install half an engine management system? And the piggyback controllers, they don't allow you to modify the tune in the old Mustang processor, so you have limited access to the old processor's already limited capabilities. Most importantly, the Pro-M EFI system is so easy to use, anyone can tune like a pro. Compared to the other stuff out there, it simply is no comparison. The car we're working on today is a 1990 Mustang GT. It has all the typical add-ons: heads, cam, intake, headers, all the things that you'd find in most of these cars. But what makes this car a perfect candidate for this upgrade are the things that have been done to it in an effort to make it run properly. A multi-tune chip, a very popular piggyback ECM tuner, and a CD ignition box. Despite these things, it runs poorly. It starts and stalls, it surges below 2,000 RPM, lacks power, and the drivability is absolutely awful. Most importantly, it's just not much fun to drive. We're going to fix all that. As I mentioned, the Pro-M EFI system for the Fox body Mustangs comes with a replacement EFI harness. The new harness is laid out just like the old one and plugs into all the factory harness connectors just like the old one did. If you're familiar with the Fox body Mustang, you know that there were a few variations of the factory EFI harness through the years. Some cars had the fuel pump relay under the driver's seat. Some were under the hood. Some cars had airbags and some did not. There are some connector variations as well, but not to worry, we have all of them covered. We have 3 harnesses that cover the Fox Mustangs from 87 to 93. We also plan to make one for the 94 and 95 Mustangs, and the 79 to 86 cars in the near future. The first harness is for the 87 to 89 cars. These cars had the fuel pump relay under the driver's seat. The air conditioning relay is on the passenger side of the engine compartment. There are 2 round connectors in the driver's rear corner of the engine compartment. There are no airbags in the 87 and 89 cars. The 87 and 88 cars were speed density, and the 89s were mass air. This harness will convert the 87 and 88 cars to mass air. If you're converting an 87 or 88 car to mass air, you'll also need to purchase one of our mass airflow meters. One odd thing about the 87 and 88 cars was that there was no check engine light in the dash. It's not absolutely necessary to add one, but you should. We sell a wiring kit to add one to these cars, and I highly recommend that you do so. More on that later. The second harness is for the 1990 only. The 1990 cars had the fuel pump relay under the driver's seat, the air conditioning relay on the passenger side of the engine compartment, and 2 round connectors in the left rear, just like the 87 through 89 cars. But there is also wiring for the airbags incorporated into the EFI harness. There are also some differences in the way the connectors are pinned, so you can't use the 87 to 89 harness in the 1990 cars. The third harness covers the 1991 through 1993 cars. 91 through 93 cars have only 1 round connector in the left rear of the engine compartment. There is also airbag wiring in these cars. The 91 cars had the fuel pump relay under the driver's seat. In 1992, Ford moved the fuel pump relay under the hood right next to the AC relay. This is how the 93 cars are as well. Our 91 through 93 harness is wired like the 92 and 93 cars and includes a fuel pump relay. If you are using it in a 91 car, the fuel pump relay under the driver's seat is no longer used. You can remove it if you'd like, but that's not necessary. It's important to note that no other wiring changes are needed to use this harness in a 1991 car. The changes are incorporated into the new harness. Just plug it in and the conversion is complete. Of course, there's also the possibility that the wiring in your car doesn't match the year of your car. Lots of cars were converted to mass air using wiring from other cars. And lots of 4-cylinder cars were converted to V8 using wiring that didn't necessarily come from the same year car. You can use the information that we just went over to determine the year of the wiring harness in your car. If you're unsure what you have, give us a call at Pro M Racing. We'll help you out. Okay, so we need to pull the passenger side seat out of the car, and we need to pull this sill plate off and this right-hand side kick panel so that we can get the old wiring harness and the old computer out and get the new stuff in. Installation is pretty straightforward. Just remove the old EFI harness and computer and replace it with a new harness and computer. Remove the old processor from the kick panel, then disconnect it from the wiring harness. You'll also need to disconnect these two connectors and this ground connection. Okay, so we need to get the old wiring harness out of here. If you're using a typical long runner style intake manifold, oftentimes you'll have to pull the upper plenum off so that you can get to these wires. But in this case, we're good, so we don't have to do that. Long runner intake manifolds, like the one that's installed on this engine, are great for making low-end torque on mild to moderately built engines. But if you want to make some real horsepower, Pro M Racing offers these single-plane EFI intake manifolds, these 1000 CFM 4-barrel throttle bodies. The throttle body comes with a Ford IAC and a Ford throttle position sensor, so it'll plug right into your wiring harness. And this really cool hidden mass airflow sensor that you can put right inside of a conventional 4-barrel air cleaner assembly. And when you put it all together, it looks like an old school carburetor setup. We also have these high flow fuel rails. The fuel rails have a 9/16 bore, so they can flow an absolute ton of fuel. And that large bore actually acts as a damper so that you've got consistent fuel flow to all 8 of your fuel injectors. So this is why we make a new wiring harness for the Fox Body Mustang engine management system. These old wiring harnesses, they're 20-25 years old. They're getting pretty tough. This is the old oxygen sensor harness. You can see that all the loom is falling off it. You can see that the sheathing is coming off from this wire. It's just right down to bare wire. This is the section of harness that was on the engine. All the locating tabs and locking fingers are all broken off. So there's really not much left to hold these two from separating. You've got a ground wire here with the ring terminal broken off. All your injector connectors, all the locking fingers are dry rotted and broken off. And then this is your main EFI harness. Somebody has butchered the mass airflow meter wiring. And same thing, these big black and white connectors here, the locking tabs are broken off. You can't really expect that your engine is going to run all that well when your wiring is in tough shape, so we just made a whole new wiring harness that plugs right in and fits just like the old one did. When passing the ECM connectors through the firewall, you need to take your time and use some caution. The connectors are a tight fit and the edges of the sheet metal can be pretty sharp. It's best to have some help for this part. Have a friend inside the car guide the harness as you pass it through. Take your time and go slow. Plug these two connectors together. Like I mentioned before, the new harness plugs into the other harnesses just like the original one did, using all the same connectors. This is the portion of the wiring harness that passes through the passenger side kick panel. When you get it in place inside the car, you're going to want to take these fuses and relays and bring them up next to the harness and tie them in place with a few zip ties. And then that area inside the car has got a lot of sharp edges, a lot of things that could potentially damage the harness. So we give you this piece of felt, and you just want to wrap this around the harness, just like that. Maybe use some tape to hold it in place. That'll keep that stuff from rattling around inside there, and it's going to keep the harness from getting damaged. You want to be careful when routing the harness in the engine compartment as well. Tie the harness securely and keep it away from sharp edges and moving parts. Like I mentioned earlier, there was no check engine light in the 87 to 88 cars. Adding one is fairly simple. We have a simple kit that includes a warning lamp you can mount in your dash and all the needed wiring and terminals all assembled in one easy to install kit. Just drill a hole somewhere in your dash or in one of the bezels, poke the wires through, and run the harness over to the right hand side kick panel and make these connections. Now if this car were an 87 or 88, you would see that there is no mating wire to this tan wire. This tan wire is the wire that's in our harness. It plugs into this connector, which is the connector that goes up to the dashboard. And you would see that this tan wire is not here. And that's where you would put this wire. It's already got the correct terminal on it. And adding it is pretty simple. You would just pull the little retainer, this red retainer, out of the connector. Take your terminal, drop it down in there, it'll click in place. Push this red retainer back in. And then in this connector, it's the same thing. You push this little red retainer out of here. And you will see that when you put the connector in place, that there is no wire to correspond to this gray one in the dash connector. So you take this wire here, same thing, you just click it up into place. Put the retainer back in. Plug these two halves back together. So again, this wire here is installed up in here. This wire here, you will take and click up into place in this little fuse holder. Take the fuse and plug it in. There you go. Check engine light's all wired up. You're ready to go. Lay the harness out in the engine compartment and put it roughly in position. It'll position itself properly as you route the parts of the harness to their connections. Leave the connections to the battery and ground for last. This connector goes to your oil level switch in the oil pan if your engine is equipped with one. If not, tie it up and out of the way. This lead is used to control the nitrous system. The Pro-M EFI processor can ramp the nitrous up gradually while ramping back the ignition timing, all with easy to set parameters in the tuning software. Look for a video on that on our website. On the subject of spark boxes or CD boxes, only use one if using forced induction and only in high boost applications, and even then only if necessary. The vast majority of you will not need one and will get absolutely no benefit from using one. If it's already installed in the car, take it out. If you're running high boost levels and you experience spark blowout, then install one. Make sure you watch the tuning video for forced induction. It has important information on how to do this properly. This lead is for an electric cooling fan. The wiring and relay are already in the new harness, and they are heavy enough to run two very large fans. If you're using an electric fan, you really should use this wire. Disconnect and remove whatever you are using for the fans now, and connect this wire instead. The Pro-M EFI processor handles all of this for you and does it the right way. Wiring is simple. Connect this blue wire to the hot side of the cooling fan or fans, and connect the ground side of the fans to a good secure chassis ground. That's all there is to it. The Pro-M EFI processor will turn the fans on and off based on engine coolant temperature and will turn them on when the air conditioning compressor runs. It also compensates for current draw on the charging system. It's awesome and you really should use it. The lead to the mass air sensor is long enough to accommodate fender well mounted mass air meters. Connect this lead directly to the mass air meter. If you have one of those range extenders installed, take it out. If you have one of those adjuster boxes installed, take it out. There should be nothing connected to the mass air meter connector other than your mass air meter. If the mass air meter is not calibrated properly for your application, either replace it with one that is, or get it recalibrated. Range extenders and signal adjusters do not work and will only cause you grief and aggravation. Do not use them. The original baro or map sensor on the firewall can be removed. It's no longer needed. Be sure to plug the vacuum line if this was a speed density car. This lead is for an optional 3-bar map sensor. These are available from Pro-M. This is only needed if you want to use the map sensor to monitor boost and use that reading to pull timing. Check out the Tuning for Forced Induction video for more on that. The leads here in the right kick panel are for your programmable outputs, 2-stage rev limiter, nitrous switches, and the nitrous indicator lamp. Again, the wiring for the nitrous control is covered in that video. Using the programmable outputs is covered in the basic tuning video. The two-step rev limiter is simple. Just run this wire over to a switch on your dash. If you're using a trans brake or a line lock, just connect it to that existing switch. This wire should have 12 volts to it when you want the first step activated. Then set the rev limit for the first step in your tuning software. When you release your trans brake or line lock, the first step is deactivated. Simple as that. Install the new processor and plug in the wiring harness. Using wideband O2 sensors, you'll need to purchase either a pair of Innovate MTXL sensors or the Innovate LC2 sensors. We stock both of these at Pro-M, and you get a huge discount on them when purchased with your system. The MTXLs have a gauge you can put up on your dash or in an A-pillar post-gauge pod. If you're putting them up on the dash, you'll need a pair of 2 1/16 diameter gauge mounts. The LC2s are the same sensors but without the gauge. We suggest you use the widebands. We give you a great package price on these, and they operate over a much broader range of air-to-fuel ratio, which allows for more precise fuel control over a broader range of operating conditions. They are worth the money. You'll find that the Pro-M EFI harness has a connector dedicated to wiring for the widebands, and if you purchase the widebands as part of your package, you'll get this harness pigtail that plugs into the harness and makes wiring the widebands a snap. Wiring is simple. The red lead in the harness pigtail goes to the red wires on both wideband O2 sensor controllers. The black lead in the harness pigtail goes to the black wires on both wideband O2 sensor controllers. The purple lead in the harness pigtail goes to the yellow wire on the driver's side wideband controller, and the yellow lead in the harness pigtail goes to the yellow wire on the passenger side wideband controller. The remaining wires on the wideband should be capped off. These are the cables that go from the wideband oxygen sensors up to the wideband oxygen sensor controllers. When you install these, I'd suggest you wrap a piece of tape around both ends of one of the cables. You're going to be poking these through the firewall, running them across the dash over to wherever you've mounted the wideband controllers, and you're going to lose track of which one is which. It's very important that the left wideband sensor be connected to the left controller and the right wideband sensor be connected to the right controller. Incorrect vacuum line routing is a very common problem. Do not underestimate the importance of a good vacuum system. Let's go over how to do this properly. Your intake manifold should have a few separate sources for vacuum supply. One of them should be designated to components relevant to your management system only. Those components are fuel pressure regulator, boost bypass valve if used, map sensor if used, and boost pressure gauge if used. Do not allow these components to share a vacuum circuit with any other components other than the ones listed. The second one should be plumbed to your vacuum accessories such as your brake booster and heater controls. This is also the circuit you would use for your vacuum source for the evap control solenoid. Run a large hose from this port to your vacuum tree, then another large hose from the vacuum tree to the brake booster. There should be a hose from the tree to a vacuum check valve. On the other side of the check valve would be the vacuum reservoir ball and the heater controls, just the way it was when it was stock. You should also have a hose from the tree to the evap solenoid. The third one should be connected to the PCV valve only. With forced induction, there will need to be a check valve in this circuit to prevent boost pressure from entering the crankcase. It's a common myth that you can use a PCV valve from a production vehicle with a turbo or a supercharger and not use the check valve. Don't do it. These PCV valves, especially the aftermarket ones, are unreliable at best for this purpose. You must install an inline check valve if you're using forced induction. The direction of flow needs to be toward the intake manifold, of course. McMaster car part number 7775K12 works well for this. You'll also need a pair of hose barbs, since the ends of the check valve are 1/4 inch NPT. McMaster's part number is 5346K18. This is a pack of 10 barbs, but they'll cost you less than buying 2 at the local hardware store. Be sure to use a good quality hose, especially for the PCV circuit. Fuel line works best for the PCV system. Regular vacuum line will soften and swell from contact with engine oil, causing loose connections and vacuum leaks. Okay, so while we're on the subject of PCV valves, when this car got here, it didn't have a PCV valve, and that story is actually a pretty common one. So the customer installs an intake manifold that doesn't have a provision for a PCV valve, so then he moves it over to the valve cover. But the valve covers that were in this car weren't baffled, so oil vapor was getting up into the PCV circuit, sucked up into the intake manifold, and of course that causes high oil consumption and fouled plugs. So he removed the PCV valve altogether and just put in a pair of breathers like this one right here, one on either side. But now without a vacuum in the crankcase, oil vapor is blowing out through the vents, and the vents get saturated with oil, and the oil drips on the valve covers, and then from the valve covers it runs down onto the exhaust. Best case scenario is it smokes all the time. Worst case scenario is it starts a fire. So the next thing he did was he removed the breathers and installed the set of remote breathers down here on the skirt. So now the oil just drips on the ground. Moral of the story is, don't use a bad combination of parts. There was really nothing wrong with any of the parts that he used. It's just they don't work well together. If you're going to put your PCV valve in the valve cover, run a set of valve covers that are baffled. Plain and simple. But definitely run a PCV valve. You should have a PCV valve. The PCV valve is going to maintain a vacuum in the crankcase. Now, rather than having oil vapors going out through the breather, air is coming into the engine, and now oil is not dripping anywhere. All right, we've got our harness installed. It's time to make our power and ground connections. You're going to want to connect the power first, and that goes right on your starter solenoid. On the terminal that has the main battery cable on it, not the one that goes down to the starter, but the one that actually comes from the battery. That's where you want to connect this lead so that it's hot all the time. And then I'm going to connect the ground. And the way we're going to do that, we're going to pull the bolt right out of the battery terminal. We're going to put our wire on the head of the bolt. You're going to want to use a couple of washers if your battery clamp has this notch in it like this one does, so that you don't distort the terminal when you're installing it. And there we go. I can't stress enough the importance of proper battery cable sizing and routing, especially if you're going to mount the battery in the trunk. Most battery relocation kits will tell you to connect your negative battery cable from the negative battery post to the chassis, and then run another cable from the chassis to the block. That's not acceptable. That'll be a high resistance connection, and it will affect your fuel injection system no matter what fuel injection system you use. You need to run a negative battery cable from the negative battery post all the way to the engine block. If you're using an aluminum block, run the negative battery cable right to the starter bolt. The cable size should be number 2 or larger. That goes for both the positive and the negative. You also need to have some sort of a connection from the block to the vehicle chassis. If it's a unibody like this, right to the firewall. If it's a full frame car, to both the firewall and the frame. I can't stress enough how important it is that this is done properly. Let's talk about distributors and plug wires. It's amazing, but the biggest names in aftermarket ignition components still fail to understand that the Ford TFI ignition distributor must be phased properly in order for the injectors to fire in the right sequence. The Mustang processors and the new Pro EFI processor use the distributor position in order to determine engine position. The design of the TFI distributor is a rather ingenious way of having both a camshaft and a crankshaft position sensor without actually having either of them, but the distributor must be installed properly in order for this to work. If you look at a stock Ford TFI distributor cap, you'll notice that there is a 1 molded into the plastic. It's there for a reason. If you look at most of the aftermarket distributors, you'll notice that there is not a 1 in the distributor cap, or anywhere on the distributor for that matter. What that means is if you have installed one of their TFI distributors in your car, chances are your injector sequencing is wrong. The number 1 is where your number 1 spark plug wire must be. This also means that the rotor must point to this stud when the engine is at number 1 top dead center compression. If you didn't do this, then the distributor is not phased properly. What that means is that your idle quality is not as good as it could be. Injector sequencing doesn't mean much above 2000 RPM, but your idle quality will suffer if your distributor is not phased properly. Most people won't even notice when they've done it wrong because they've installed the cam and have a rough idle anyway, but your idle will be better with a properly installed distributor. You can identify the number one position on the cap by removing it and looking at the pickup module. The number one stud is directly above the pickup module. The other thing about these distributors is the quality of the shutter wheel inside. This is what tells the ignition when to fire each cylinder, and if the width of the teeth on the shutter is inconsistent, so is the spark delivered to each cylinder. Most of these aftermarket shutters are well outside the acceptable tolerance, so if you actually took the time to check the advance on all 8 cylinders rather than just number 1, you'd see that there is a significant difference from one to the other. Here's something to consider. Ford TFI ignition has been around for over 25 years. They've had plenty of time to get this right, and they haven't. And this is not the only area where they've failed. Keep in mind that there is nothing complex about a distributor, and yet, 25 years later, they still have not gotten this right. What's really scary is that these companies sell fuel injection systems too. Not to worry, one of the cool things about the Pro-M EFI processor is that it can take the awful signal generated by these poor quality distributors and average it out and deliver consistent spark to all of the cylinders. The consistency of the advance delivered to the cylinders with the Pro-M EFI system actually rivals that of a high data rate coil-on plug system. It's that good. And here's another cool thing. Remember the old troublesome TFI module? You'll be happy to know that we don't use it. It stays on the distributor, but acts only as a connector for the harness. The coil is fired by the Pro-M EFI processor. You could actually install a bad TFI module on your car, and it would not matter. You should install a good set of plug wire mounting brackets. All too often, people will spend a bunch of money on a good set of plug wires and then let them burn up on the headers. Get a good plug wire mounting kit, keep your wires separated, and off the headers. If you haven't already done so, you'll need to install the Pro-M EFI calibration tool onto your laptop. Open up the software and set up some basic parameters. If you opted for this to be done for you when you placed your order, you can skip these next few steps, but pay attention anyway, in case you want to make changes in the future. First, go to the engine parameters section and enter the bore and stroke. Now remember, if you have a 302 and it's been bored 30 over, it's not a 302 anymore. The bore has changed. Make sure you enter accurate data here. This engine is a 302 bored to 306. The bore on a 306 is 4.030 and the stroke is 3. You'll find a list on our website which shows the bore and stroke of most popular engines. If your engine is not listed, you'll likely find what you need by doing a search on the web. Next, you need to enter the fuel injector's high and low flow rate values into the tune. The high flow rate will be the injector's actual flow rating. If using our fuel injectors, the low flow rate is roughly flow rate times 1.25. For example, if you were using 36 pound-per-hour injectors, 36 would be your high flow rate value, and 45 would be your low flow rate value. This car has Ford Racing 30-pound EV1 injectors, and the advertised low flow rate for these is 33. Injector high and low slope rates are typically available from the manufacturer and should be calculated at a fuel pressure of 39 to 40 psi, not 43.5 psi as they are often rated. If the flow data is only available at 43.5 psi, then divide the high and low flow ratings by 1.054. This will give you the flow ratings you need. If the low flow rate is not available, figuring it out is pretty easy to do with our software. Injectors tend to vary a bit at lower flow rates anyway, so if you don't have the low slope value, just multiply the advertised flow rate by 1.15. This will give you a starting point. We'll fine-tune it later with our software. Next, you need to set the rev limiter. If you're using an electric cooling fan, you must enable that function in the tune. All the parameters for the cooling fan operation are all preset. All you need to do is enable the fan control. Next, enter the meter's transfer function into the tune. Make sure the transfer function is accurate. If the meter is a Pro-M, use the transfer function sheet provided. If not, it'd be best to send it into Pro-M to have an accurate transfer function sheet generated on the flow bench. If using the meter in a blow-through configuration, the relevant ducting and meter should be sent to Pro-M for an accurate transfer function. Remember, when entering the transfer function, be sure to set the English metric button to whatever units you are entering from your transfer function sheet. Pro-M transfer function sheets provide airflow data in both kilograms per hour and pounds per minute. The tuning software will accept either English or metric values, but you must set the English metric button appropriately while entering your values. Also, if entering the values in English, please note that the tuning software is looking for values in pounds per hour. The Pro-M flow sheet provides English flow values in pounds per minute, so those values will need to be multiplied by 60 before entered into the tune. Also notice that the values in this table, as well as in all the tables, are in ascending order. They must be entered this way. Now save your changes. You're done for now. We'll make more adjustments after the engine is running. To save your changes to the tune, you can either click Save, or you can save the change as a whole new calibration file with a new name. To write a calibration file to the processor, the engine must be off and the key must be on. Make sure you have the file that you want to write to the processor opened and on the screen. Then click on the Write All button and wait for it to finish. Do not turn the key off while the calibration tool is writing the file. If you're using widebands, you'll need to set up the parameters in the wideband O2 sensor controllers. This part is done in the wideband controllers themselves and not in the Pro-M EFI processor. The parameters in the processor have already been set up for you. To do this, load the software on your laptop. You'll get a CD with each of the widebands, but obviously you'll only need one of them to install the software to your laptop. You do, however, need to remember to set up both wideband controllers. If your laptop does not have a serial port, you'll need to purchase a USB to serial adapter. They are available in any office supply store. The adapter will come with a CD that contains the drivers for the adapter. You'll need to install the drivers to your laptop. Now follow the instructions that came with your widebands and set the parameters in the wideband controllers as follows. 0.5 volts equals 0.5 lambda. 4.5 volts equals 1.5 lambda. 0.25 volts equals warm-up. 4.75 volts equals fault. Save your changes and remember to do both controllers. Also, be sure to perform the free air calibration on both widebands. This is very important. Okay, it's time to fire it up and make some basic adjustments. The first thing we need to check is base timing. Do not assume that the timing is still the same as it was with the old harness and computer. It's not. Setting the timing is done just like it was before with the old harness. Get the engine warmed up, then disconnect the spout connector. You'll notice that we use a single terminal weather pack connector rather than the old Ford shorting plug. You can't lose the shorting plug this way. Connect a timing light and set the timing to 10 degrees before top dead center. Not 12, not 8, set it to 10 degrees. Reconnect the spout. If the engine won't start and you suspect that it's because the timing is too far off, you can rough in the timing as follows. With the spout connected, crank the engine and check the timing. It should be at 10 degrees advance with the engine cranking. Adjust it if necessary. Once it's running, set the timing as outlined earlier. Next, check the fuel pressure. Remember, if your fuel pressure gauge is mounted in the engine compartment, you must check the fuel pressure when the gauge is cold. If the engine has been running with the hood closed and the gauge is warmed up, the pressure reading will be inaccurate. Fuel pressure should be 39 to 40 psi with the vacuum line removed from the fuel pressure regulator. While the vacuum line is removed, connect it to a vacuum gauge and record the vacuum at idle. With the vacuum line still removed, snap the throttle and make sure the fuel pressure remains constant. Also have a look at the fuel pressure gauge at idle and make sure the needle is rock steady. Any fluctuation at all is a clear indicator of fuel pump cavitation. Reconnect the vacuum line. The fuel pressure should drop half of whatever your manifold vacuum reading was. If any of these things are not true, you have fuel supply issues. Fix them now before you drive the car. You will find a video on our website dedicated entirely to proper fuel system design. Next is base idle speed. First, if you have one of those spacer plates installed between the IAC and the throttle body with the air adjusting screws, you need to remove it. Be sure to use a new gasket when you reinstall the IAC. Bring the engine up to operating temperature, which by the way is 190 to 195 degrees. Please don't be one of those guys who thinks colder is better. That ancient thinking was wrong in the 50s and it's still wrong today. Your thermostat must be either a factory Ford 192 degree or an aftermarket 195 degree. To set the idle speed, disconnect the IAC connector and set the base idle speed with the throttle stop screw. The base idle speed should be set to an RPM where your engine idles properly. Stock engines will idle down around 750. The more aggressive the camshaft, the higher the base idle will need to be. Base idle settings as high as 1000 RPM and even higher are not uncommon with very aggressive cams. Do not rely on your tachometer to set the base idle speed. They can be pretty inaccurate. Open up a variables window and drag the RPM value in there. Once you have the idle speed set properly, reconnect the IAC. Now go into the tune and set the base idle speed parameter. Set this value to whatever RPM you set your base idle. Next, check your TPS voltage at idle. The engine does not need to be running for this, so do this with the key on and the engine off. It should be 0.95 or less with the throttle in the idle position. I know you've been told 0.98. Please change it to 0.95 or less. 0.98 is not correct and it never was. In fact, the Mustang computer worked best at 0.90 or less. The Pro-M EFI processor will work fine with it as high as 0.95. Next, let's fine-tune the low flow rate for the fuel injectors. This is pretty easy to do. Run the engine until it's up to operating temperature. With the engine at idle, switch over to the working page and switch closed-loop fuel control to disabled. Then watch the wideband O2 sensors as you adjust the low flow rating until stoichiometric air-to-fuel ratio is achieved. It is not uncommon for there to be a small difference in the readings from one bank to the other. There are many factors that can cause this. Things such as slight variances in flow rate in the injectors, engine firing order, and intake manifold design can cause this. If this happens, adjust your low flow rate until you have one bank just above and one just below stoichiometric AFR. The O2 sensors will correct this once you switch them back on. If there is a very large difference, say more than 1 full point, then you may have a vacuum leak or possibly a bad injector. Fix your issue before you continue. Once you have your low flow rate adjusted properly, switch closed loop fuel control back to UEGO, then switch back to the reference page and save your changes. Remember that any changes you make to your tune are not saved until you save them, and they are not installed in the processor until you tell the calibration tool to do so. To save your changes to the tune, you can either click Save, or you can save the change as a whole new calibration file with a new name. To write a calibration file to the processor, the engine must be off and the key must be on. Make sure you have the file that you want to write to the processor opened and on the screen. Then click on the Write All button and wait for it to finish. Do not turn the key off while the calibration tool is writing the file. Lastly, you will find that your check engine light is on. That's from disconnecting the IAC during the idle setting process. This can be cleared with the scan tool feature in your laptop. Clear the codes and start it up again. If the check engine light stays off, then you're done. If it comes back on, then read the codes to see where the trouble lies. So here's our finished product. Despite the fact that the combination of engine parts could not be worse, it actually runs great. What do I mean by a bad combination of parts? The lower end in this engine is completely worn out. Compression is down to between 105 and 130, and the amount of blow-by is incredible. The heads are too aggressive for a 302. The camshaft has way too much lift and duration for a street engine. And when you combine that with 1.7 ratio rockers, well, you simply have something that was not very well thought out. Despite that, it runs great, idles without surging, and cruises down the road beautifully, even at low RPMs. This car would barely run below 2,000 RPMs when it got here. So that's it for this segment. Be sure to check us out on the web at proemracing.com for other helpful videos. Until next time, I'm Chris Richards for Pro-M Racing.